Now we're looking into a separate question. For the first video, we did two questions. Now we're going to be doing the third one. So it says that a ball of 2 kg is dropped vertically into a trolley of mass x moving to the right at 10 meters per second. Right. So let's just consider what's going on right now. So you have a ball 2 kg dropped vertically on a moving trolley of mass x, and this trolley is moving to the right at 10 meters per second. We don't know what velocity this is moving, but we know what the velocity that this is moving. The velocity of the trolley is reduced, right? So it becomes 8 meters per second. Still in the same direction, to the right. Calculate the trolley's mass, so we don't know the mass of that. And it said that after this collision, after this entering the trolley, the ball stays on the trolley, so they move together. Um, so here we go. Here we have a hint. This last statement right here that says that the ball stays on the trolley tells you that after the collision, these two are going to move in the direction or in the original direction of the trolley at a given velocity, whether or not if the velocity is going to be given or not, but yeah, it is given. So basically, this ball comes into this trolley when it's moving, right? Gets inside, give you like a four-dimensional drawing of what's going on right now. This is a very terrible drawing, but it'll have to do. So it gets inside of the x kg trolley. It weighs 2 kg. Irrelevant information. This is actually irrelevant. You'll get to know why. So it's moving in that direction, right? And once this one enters, if you think about it, if you if if you were stepping on a scale in a clinic, they will tell you to take off your shoes, take off any like take out your phone, all that stuff. And the reason that they tell you to take out your phone is because they want to weigh you, not the added weight of you, the shoes, the phone, and all that. Even those little, 500 grams and all that stuff. That stuff matters because it's gonna change the perception of your actual weight. So in this term, the ball here is going to add 2 kg to our x, right? And due to that, we have the following things. So we have the fact that, so let's remember the strategy that I taught you. So you have the ball and you have the trolley. You have to indicate whatever it is that's going on. So with the ball, the mass is 0. No, sorry, it's 2 kg. And then with the trolley, the mass is x. We don't know it, right? Let's make this mass 1. Let's make this, oh, actually, let's just say MB and MT, since the first letters of these two words are different. So you have that kind of situation. And in terms of the velocity of this one, well, this is where you get to look into what exactly should you consider. So the fact is, they want you to find the trolley's mass. For you to be able to find the trolley's mass, you have to consider the motion of the trolley, alright? And remember, it's called linear momentum because it's going to be heading on a straight line in one direction, and momentum will be conserved in that straight line. It's going to change in that straight line, but in terms of conservation, we're just talking about the sum of the initial and the sum of the final. But it's just a matter of, for you to be able to calculate this, you need to have perspective, and the perspective has to be looking into what exactly are you trying to find, and how or what kind of perspective will allow you to find that. So the only kind of perspective that would allow you to find that is if you were looking in the horizontal direction, because that's the place where the motion of the trolley is located. So in the horizontal direction, the ball does not have any velocity. It's actually 0 because it's moving downwards. So the initial, say VBI is 0, and then what about VB final, right? VB final, well, after collision, it goes with the ball. It stays in the trolley. The henceforth VB final has to be what? 8. And then for the trolley, V trolley initial Well, you know this, it's 10. And then V trolley final is 8, right? Now, one of the things that I need to also mention here, which you should I should be getting as a smacking for that, is that I always emphasize the fact that before you do any other thing, please choose your own direction. So your direction here, we're choosing to the right is positive, horizontal to the right is positive. Given that fact, all given that fact, um, we would have to consider the fact that every single thing here is going to actually be positive. So because there wasn't really a change in direction in any way. So yeah, let's make our calculation. So you're going to be saying m, let's say mb vbi plus mt vti is equals to mb vb final plus mt vt final, right? Remember again, always write the formula that is from the formula sheet first because that earns you a mark. Secondly, we enter the masses. The mass for the mass for the ball is 2, and then in terms of the horizontal direction, it has a velocity of 0. And then when you consider the trolley, it has a mass of unknown and its initial velocity is 10. That's going to be equal to, well, the mass of the ball is that, and the new velocity is 8 plus the x and 8 as well, right? So as you can see, the velocity is the same. This is a similar question to the one that we had before, but it's different because now you're dropping it, right? I'm trying to bring you into a different space here. So yeah, you would be having x10 is equals to 16 plus 8 6. This one goes this one goes on this side. You're going to be having yourself 2x is equals to 16. Divide both sides by 2, you get x is equals to 8 meters per second to the sorry, not 8 meters. That's going to be x is equals to 8 kilograms. All right, we're looking for mass, don't forget that. So that's going to be your answer, 8 kilograms. Hopefully you understand this. It's quite a fairly easy thing, but it's just showing you the same type of principle in a different perspective.